Hi, audience. Hello, live stream. I'm Rachel, Creative Director of Material Design. This is Kunal and Phil, senior designers on the team. Let's start out with why are we doing this? Why are we talking about this? Why is a design systems team concerned with machine learning? OK, let's do a quick primer for those of you maybe unfamiliar with machine learning. I love using cats to talk about ML, so humor me. So what is machine learning? It basically gives computers the ability to make predictions and solve problems without specific instructions. So by identifying really complex patterns, machine learning can be used for a variety of product experiences. Identifying music, responses in a chat app, identifying imagery. And products, as many of you saw yesterday, like MLKit and Firebase, really make this technology available to developers of any skill set. But the issue is this technology is not effective if users can't understand its benefits. So this is an example of one of the original demos out of MLKit. Sorry, MLKit, if anyone from MLKit is in the audience, of looking at some object detection patterns. Now, it's picking up the dog to some degree, but how is this experience super beneficial to users seeing this on the front end? So the goal of material design is to build a design system that harnesses technology like this into a beautiful and usable interface. And this well-designed interface is what's useful to people. But a well-designed interface also allows you to implement the technology faster and provide assurances that your audience and your users will understand the interface and it will work for your users. One of the most important things about a design system machine learning are really the design solutions when things do not go as planned. Because machine learning can be fluid and unpredictable and augmented by users, these situational design solutions must be considered for a functional product experience. So there's no single design pattern, and as many of you probably know, that encompasses the entire kind of myriad of things that machine learning can do. This is an example of the plethora of features that machine learning can power. We selected some of the most prevalent machine learning-powered patterns, visual search patterns. What does that mean? Really, it means using your camera to search the world instead of more traditional text input options. Kunal and Phil are going to talk about these patterns upcoming. But before we start, I want to mention a few tactical pieces of information to make this guidance more understandable. What are we providing? We're providing 3 visual search pattern articles on material.io, which is the guidelines site for material design. There's also a great demo app provided by the MLKit team available on GitHub that is specific for material design and specific for these patterns that you can download. And there's also really great demos from Adidas, IKEA, and Flutter that we'll talk a little bit about later. And with that, I'm going to hand it off to Kunal to start talking about the patterns.
All right. Thanks, Rachel. So as Rachel mentioned, we're going to focus on 2 MLKit APIs today and walk through 3 patterns. As we were working through the object detection and tracking API, we realized there were significant differences in user experience for how a user would go through this flow with the streaming mode of the API, which uses a live camera feed, or the static mode, which uses a provided image. So we've split that one API into 2 separate design guidelines based on the mode that you're using. And as we go through these flows, for those of you who are familiar with material design, you'll see a number of familiar components, like a top app bar, buttons, dialogues, and also some new elements that we've added, such as the reticle and object markers, to extend the experience to work for these visual search patterns. In addition, building on our announcement last year of material theming, we wanted to make sure that just like the rest of material design, these new visual search experiences and the elements that we were adding could be customized to match the look and feel of your application. What you're seeing here is a sticker sheet of visual search elements for our material study shrine. And we'll be using this as an example in all of our flows. So now I'm going to talk about the first pattern we're going to walk through, which is object detection in a live camera. You may be asking, what do I mean by object detection? What does live camera mean? And why should I care about either of those terms? So object detection is really the first step of a visual search journey, as Rachel was talking about. The advantages of searching by an image or through visually is that if users don't know what to type or say, they can use an image instead to do that work for them. In addition, with the streaming mode of MLKit's object detection and tracking API, they can do this without having to manually take a photo themselves. Just point at an object and learn about it. Our guidelines for this flow are going to cover tracking a single prominent object in the user's camera. So how does this work technically? Users can detect an object on their device using MLKit's object detection and trapping API. The API is going to crop the camera frame just to the image area of the detected object and send that along to your own machine learning model for classification and more information. Once you have results available, those are sent back to the user. When we were thinking about designing these experiences, we separated the user's experience into these three phases: sensing, recognizing, and communicating. Let's take a closer look at each one. So in the sensing phase, this is when users have opened the visual search feature in your app, and the app has begun looking for an object. This could be to learn more about a plant in a garden, an item at a museum, or a shoe that they want to purchase. For first-time users, we want to be sure to explain how this feature works. Many users are familiar with using their smartphone camera to take photos, but not as kind of a remote control in which to learn about objects around them. So we recommend having a light and fast one-screen onboarding experience that focuses on what the user can do, what kinds of things they can detect, and using animation to show that moving their device to actually identify an object may be required. After that onboarding process, when they're in the experience, we want to communicate that the app is looking for objects in the camera. As I mentioned, our guidelines for object detection in a live camera cover using the prominent setting of MLKit's API, which is going to look for the largest object in the center of the camera. So we want to draw users' attention to that area and let them know this is where they have to search. We do that using this new visual element that we call the reticle. It's animated to draw attention to the center of the screen and to let the user know that it's actively looking for items. In addition, we reinforce what the reticle is doing with a tooltip at the bottom of the screen that prompts the user to point their camera at an object. A user may have trouble detecting objects based on conditions in the environment around them. Maybe there's not objects of the type that are recognized by your app in their environment. Maybe it's too bright or dark, or objects are too close together for the app to get an accurate reading of objects in the environment. What we recommend doing is setting a detection timeout here so that if you notice that users haven't detected something after a certain amount of time, you can bring up an error message through a banner and direct them to help to troubleshoot the issues that they may be having. In the second phase of the experience, when the user has found an object that they want to search for, the app needs to detect that object and begin the visual search for them. When we do recognize an object in the camera, we want to let the user know that we've identified this by adding a border to the bounding box coordinates that we're getting back from the MLKit API. You can notice that the frame here is rectangular. This matches the coordinates that you're going to get back from the API, and also lets the user know that this is going to crop an area maybe a little bit larger than the object that's being shown. However, when we detect an object, we don't want to necessarily begin a search immediately. Users may be moving their device around, looking for objects, and we don't want to start a search for every single thing we see. That's not going to align to their expectation, and it's going to be very expensive for your app to do. Instead, we need some light signal to confirm that users are actually interested in this object, that they want to search for it. And the way we do that is by asking them to keep their camera still for a moment. Sort of hover over that object for a brief moment to let us know that they're interested in searching for it. That amount of time before we wait to begin the search can be preset by your own application, so it can be customized. We want to communicate that to the user by including a loader within that center element, the reticle, so they know how much longer they have to keep their device still. Once they do indicate that they want us to search for this object, the first thing we're going to do is pause that live camera feed. This is a strong signal to the user that they can now move their device to a more comfortable position without losing track of the object. And the second thing we're going to do is remove the reticle and replace it with an indeterminate progress indicator to let them know that we've started running a search and are looking for results for this item. At this stage, one thing that can go wrong, or that you want to keep an eye out for, is how far the user is from the object. So while an object may be detected from a distance, you may want to set a minimum size for detected objects in order to begin your search. And this is because the image that's going to be used by your own model to find results is based on what's in the camera view. So if the object is very small in the camera, you may be missing details that are going to be helpful for identifying that item. So we included a partial border style for you to use for an object that's detected but is maybe too far away, and tips on how to message and change the reticle style to let a user know that they need to move closer before we can actually search for this object. In the last phase of this experience, the app has results for that object that they're ready to send back to the user, and the user needs to be able to focus on them to complete their task. The first thing we want to do is use a thumbnail of that image of the detected object and present it above the results space. This serves two important functions. One, it's a bridge between the recognizing phase and the communicating phase. It confirms what the user was looking to search for and provides it to them on results for easy comparison with any information that you're returning to them. The second thing is that we're using a modal bottom sheet to present the results. And this has a couple advantages. One, modal bottom sheets come with this layer that separates the sheet from the rest of the app UI, called a scrim. This scrim darkens the camera view behind and brings more emphasis to the results, and also provides a way for users to return to the camera by tapping on it. Users can also return to the camera to conduct another search by tapping the header of the result sheet. In terms of the layout for results, we really want this to be based on the needs of your app. What is the specific kind of content that you're presenting to users? How many results are you returning? And what is your confidence in the results? If you're returning multiple search results to a user based on a visual search, we recommend using a list or grid format to show those results. And if you just have a single result or a high confidence result that you want to promote, customize that layout to your needs. If your results are mostly low confidence, which is to say that your model doesn't believe that it's very similar to the object that was detected, it doesn't have a lot of faith in its prediction, let users know that they may want to search again. You want to make sure that you're also setting a confidence threshold for what results you're presenting to users. And if the results are kind of borderline, let users know that they can search again and maybe provide some tips on what they could do to improve in case the results don't meet their expectations. If no results are found, maybe because the user was too far away from the object, didn't capture it from the right angle that was expected, or the environment affected how bright or dark the object appeared, you want to make sure you have a way to message these error cases and direct a user to help for more information. A lot of these issues are not going to be things that you can detect or help a user with in their app, and are things they're going to need to change about their environment. Maybe turning on their camera flash to increase the brightness of the object that's being detected, or change their position to try photographing the item from another angle. So I mentioned that we were going to look at how these experiences could be customized. So let's take a look at how this live object detection flow can be customized to match your app. So we're going to use Shrine, which is our material study for a retail app. Has a very kind of like minimal and clean aesthetic. It uses these angled corners for key elements that's based on the geometric logo that Shrine has. And it has this light pink brand color. So in thinking about how this gets applied to a visual search experience, we wanted this to feel seamless. We want these to blend in with the rest of your application and carry over key elements from color, typography, and shape. If we take a closer look at some of the new elements we introduced here, like the reticle, in our baseline flow, it has this very rounded shape. But since Shrine has a more geometric approach to the app and to key elements, we've gone with a diamond shape instead to reflect the brand and fit in with the rest of the key elements of the app. Our tooltip, which in the baseline form uses Roboto and a black container, now uses Rubik, which is Shrine's font, and a light pink background color that's used in the rest of the app. So now that we've walked through how detecting objects from a live camera works and how it can be customized to your app, I'm going to turn it over to Phil to talk about how this works in a static image.
Wow. If you like that, wait till you see what's coming up next. Thanks, Kunal. So object detection in a static image allows users to select an image on their device and then detect up to 5 objects located inside of that image. This feature is really useful for when users would like to analyze an image that they captured before, or if they're not able to detect something right there on the spot. So one of the ways that this can be integrated is in a search flow, like what we see here in this example, where a user is looking for plants in a photo that they took. So let's break down the technical flow of this experience. This is pretty similar to the live camera flow that Kunal shared earlier, just that here our source is different. We're using a static image instead of a live camera. So first, the objects are detected on device using MLKit. Then the objects are classified with your own model. And finally, the results are presented back to the user. Now, as before, we've split this flow into 3 distinct phases. And these should probably look familiar to you at this point. So here we have input, where the user selects an image to search. Recognize, where we wait for the objects to be detected and identified. And communicate, where we review the results and complete the task. So in the input phase, we're introducing the flow to the user, and we ask them to provide an image to search. When the user opens the feature for the first time, it's important to explain how it works so that there's a better chance for a successful search. And the best way to do this is, again, with a simple onboarding screen. So as Kunal had mentioned earlier, we're limiting this to 1 screen and providing a short explanation for how this feature works. So it's important here that we don't want to use this moment to go through every possible error that a user can encounter. Instead, we're focusing on the user interactions. Like, what does the user need to do to get to the information they want? And once we get through the onboarding screen and into the image selection screen, we recommend using the operating system's native selection screen so that users are already familiar with how to select an image. So that's the input phase done. So now we move on to the recognize phase, where we enter a transition state while the user is waiting for objects in the image to be detected and identified. In this phase, we're using an indeterminate loader paired with a tooltip to clearly communicate to the user that they should be expecting a short delay. And in addition, we're also using a translucent scrim on top of the image. So this does 2 things for us. The first is that it helps to obscure the image slightly so that users know the image is not quite ready to interact with yet. The second is that it helps provide adequate contrast for the loader and the tooltip to be visible on top. And sometimes certain factors can affect whether an image is suitable for object detection. These are things like poor image quality, the object in the image being too small, low contrast between an object and its background, or an object being shown from an unrecognizable angle. Other times, it might not be with the image itself, and more that the user lost connection to the network. So if a user encounters an error, it's important to anticipate them and facilitate a smooth experience by explaining the issue in a banner and giving the user an opportunity to try a new image. You can also include a way for the user to learn more in a dedicated help section. Finally, once we have the objects detected, we move on to the last phase, communicate. So in this part of the flow, we show the user which objects have been detected and give them the opportunity to inspect those results. So the way that we identify detected objects is through these cute little object markers. They should be placed in the center of a detected object's bounding box, and they're elevated with a shadow to make sure that they're visible against an image. So remember how earlier Kunal talked about using a thumbnail in the results view of the live camera mode? This is conceptually doing the same thing, right? We're helping the user to compare the object in the image to the object in the results. And in addition to the object markers, we're giving the users a preview of the results through these little mini cards at the bottom. We place them in this horizontally scrolling carousel at the bottom of the screen so that it's easier for users to reach. And finally, how do we encourage users to explore and interact with their results? With a little something called the power of design. The first is through the motion transition. So the way that these elements appear on screen is staggered, and that helps to demonstrate that there are multiple results in view. And second, the tooltip at the bottom allows us to use language to prompt the user to explore the results. And finally, at the end, Notice how as the carousel is being scrolled through, the markers scale up in size as its corresponding card scrolls into view. So this helps the user to draw a relationship between each card and its matching dot. And then tapping each card or the object marker brings up more details about it in a bottom sheet. Same as what Kunal had showed us earlier in the live camera mode. And now, again, when we talk about errors and issues, it's important to account for result confidence. If a search returns a result with only low confidence scores, you can let the user know at the bottom of the list itself with links to search again and tips to improve their search. And aside from low confidence results, a search can just fail and return without matches for several reasons, like if the object isn't in a known set of objects, or if the image is low quality. So when this happens, we recommend displaying a banner that guides users to the help section for more information about how to improve their search. OK, now in terms of theming, let's quickly talk about how we can take these baseline patterns and express them, customize them to express your brand. Once again, we're going to use the example of Shrine that Kunal shared earlier. So here's an overview of what those key phases look like. In these screens, the user might tap on the image search icon into the top bar, select an image from their device, and then explore the results in the following screen. Like we mentioned, Shrine's visual language is all about using those angular shapes, right? So we've expressed that here through the object markers, where we turn them from circles into diamonds, and through the cut corners of the cards. And of course, we've transferred the typography and the color scale of Shrine into the card title and shape. So that's object detection in a static image in a nutshell. So now I want to welcome Kunal back to the stage to welcome you through the last experience, barcode scanning.
Thanks, Phil. So barcodes are an easy and convenient format for passing information from the real world to your device. MLKit's barcode scanning API reads most standard barcode formats and provides an easy way for your own app to be able to recognize barcodes without users having to open up a separate application. And this is a great way to either have users be able to search in a different way or to automatically input information by scanning a code rather than by manually typing things in. So how this works technically is the MLKit barcode scanning API can detect most common one-dimensional and two-dimensional barcode formats, and then read the value. And if that value is like a string, an ID that needs to be looked up, you can send it off to your own database to get results back and present them to the user. But one cool feature of the barcode scanning API is that if the barcode's value is in one of several common like structured data formats for contact information, event details, things like that, the API can automatically parse that structured data and let you present it immediately to users without you having to do any extra work. So we thought about this experience in the same 3 phases that we use for the other live camera experience, our object detection flow. So I'm going to try to focus on what's unique to barcodes here. So in the sensing phase, we open up the feature. The app has begun looking for barcodes. We want to do that same type of onboarding. Keep it simple, keep it short. Focus on the motion that users might need to do to get a barcode into view to scan. And once they're in the experience, instead of the reticle that we used in the live object detection flow, we have what we call a barcode frame instead. This barcode frame is also at the center of the screen, but it's setting the area that the barcode will be automatically scanned in once entered. So providing a more prominent area for users to place the barcode to scan. And we're also animating it to draw attention to the center of the screen. One last thing to note is that the aspect ratio of this barcode frame can be adjusted to match your own application. So if you're only looking to scan QR codes, then this frame can take on a more square shape to provide another hint or cue to the user that those are the types of barcodes they should be looking for. If they have any difficulties with detecting objects, detecting barcodes, as we covered in our previous flows, we want to have the same kind of error case and error styles for the barcode frame and for the rest of the app that we mentioned in the earlier flows. In the recognition phase, the user scanned a barcode, the app has read its value, and it's loading results. So similar to what we talked about in object detection, for most simple barcode formats, you shouldn't need to really set a high minimum detection size. Most formats are graphically easy and should be able to get read pretty quickly once they're in that barcode frame area. But more complex formats, such as PDF 417, have a lot of detail that will need a higher quality image in order to be accurately read by the barcode scanning API. For these types of formats, we recommend setting a minimum detection size and using this partial fill style for the barcode frame and a tooltip message to let the user know that they need to move closer in order to get a higher quality image to be scanned. If you need to send information about the barcode off to another database or other part of your app for processing, we want to communicate any loading time to the user by turning the barcode frame into an indeterminate progress indicator. If the value can be read immediately, you can skip straight to showing results. So when we do have results available to users, there are a couple unique things about displaying results that we haven't covered in our previous flows. The first is what I mentioned in the technical flow demonstration, is that the barcode scanning API can read both structured data and what I'll call unstructured data, or data that you need to look up and that may have custom information. For structured data that's in key value pairs, text fields provide a really great format for representing this information. The key and value kind of relationship matches really well to a text field's label and input areas, and it gives you room to present actions to copy, and also a consistent format for users to scan the different types of information you may have available. For more custom information that you're looking up and returning, customize the layout of the container that you're using to present the results. Another difference with barcode scanning is that the types of tasks users are doing may be very different. For cases where users are going to be scanning multiple items, let's say they're in an e-commerce app and maybe doing price comparison and looking up multiple items, we recommend displaying the barcode results in a modal bottom sheet so that users can easily return to the camera and scan another barcode. But for tasks like completing a form, like scanning a gift card and getting its balance added to your account, displaying that information over the barcode scanning feature doesn't make a lot of sense for the user. It's actually creating more work for them. So we recommend for these types of flows where you're completing data entry is returning a user automatically back to the previous screen with the appropriate fields filled in. We want to do that work for them when we can. A number of tasks may fall somewhere in between. For reviewing contact information, for example, you may want to edit someone's name, add additional notes before you save that information and exit the barcode feature. So we recommend bringing those results up in a modal bottom sheet or a full screen dialog so that if a user needs to go back and change anything, they can. And they have this lightweight way of editing that information before saving and exiting the feature entirely. So as we did in the other flows, I'll quickly share an example of how the barcode scanning can be customized to match your app. So we're seeing here in the flow, we're bringing in some of Shrine's colors and typography again. One thing to call out here is the scrim that separates the area that can be scanned for the barcode from the rest of the camera view is using Shrine's text color instead of pure black for a slightly more branded experience. In addition, if we take a closer look at the barcode frame, when we usually have these slightly rounded corners, we're using sharp corners to reflect the sharp cuts in the logo. The same typography and color choices for the tooltip that we discussed in the previous flows carry through here as well. So we've gone through 3 different patterns in a lot of detail, thrown a lot of information and micro interaction decisions at you. But hopefully you noticed there were some common themes across all 3 of these flows. I'm going to turn it back over to Phil to talk about some of the design principles that we use to guide our decision-making process.
Thanks, Kunal. So now that we're familiar with these 3 experiences, why don't we zoom out for a second and walk through the core design principles that you should keep in mind as you're implementing these patterns into your products. Our first principle is to make the camera UI minimal and meaningful. We want to make sure that the central means of input, which is the camera, is unobscured. And when things do have to be overlaid on top, like a reticle or an object marker, we're making sure that they're legible against any kind of image, light or dark. Our second principle is to keep users informed at every moment. These new patterns can be pretty unfamiliar to users, and explaining what's going on at every step is really important to ensure a smooth experience. So first, really rely on these design phases that we've shown you to help organize your flows. And use multiple methods like language, motion, components to implicitly and explicitly communicate to your users what's happening now and what they should expect later. And finally, outside of the main flow, introduce users to the essentials of your app through an onboarding experience, and give them a persistent way to learn more about the feature through a dedicated help section. Our last principle is to anticipate opportunities for issues. So this is what Rachel was talking about at the beginning, about designing for the fringes of these use cases. These flows are prone to errors from a variety of factors, and it can be really frustrating for your user if you don't take these factors into account. So before designing these flows, before even getting into the design side, really test and learn the model's boundaries. What is it good at doing? What is it bad at doing? And what common errors might you encounter because of those boundaries? Also, always account for environmental conditions. So most apps wouldn't otherwise care how bright or dark a user's environment is, but for something like visual search, that's really important, right? So these are also common issues that are applicable to all kinds of users, regardless of their technical familiarity or how good their device is. And finally, adapt your design based on the confidence of your results. So this is less about like explicitly communicating the confidence at every step of the way, but more about accommodating when you do have suboptimal results so that users have a better understanding of where their information is coming from. So to recap, here's our 3 high-level design principles. Make your camera UI minimal and meaningful. Keep users informed at every moment, and anticipate opportunities for issues. And now to close things off, I'm going to throw it all the way back to Rachel.
OK, I'm back. Let's close this out. OK. So really quick, I'm going to talk about some collaborations we did that I mentioned in the beginning. We worked with IKEA and Adidas. We worked with these 2 early access partners to really look at what these flows would look like in actual products, and most specifically using real training data. It was really fantastic to work with these teams, not only to get feedback, but to really see how these teams approached theming. How they really took this same pattern of live object detection, but really tailored really minute details to their brand. You can check out both of these demos in the AI/ML tent, which is very close by. Secondly, we worked with Flutter. They have downloadable source code on GitHub that you can see a hypothetical barcode flow. It is using our FAW e-commerce app Shrine to showcase what this hypothetical flow would look like, and really valuable to see what that might look like in practice. OK, real quick recap on some of the resources to actually help you implement. MLKit and all of the dev docs and the demo that is really specific to material design is available on the MLKit site and on GitHub. For those of you who were at the talk yesterday, the People in AI research team recently launched a guidebook, a really fantastic resource providing tools and best practices for designing with machine learning. That's available at pair.withgoogle.com. And of course, all of these 3 patterns are available on the material.io site in depth and in detail. And with that, thank you for coming to our talk. We are going to be in the sandbox right next door, right after, if you want to ask us any questions. And goodbye.